हेलो। आज हम लोग बात करेंगे केमिकल किनेटिक्स के बारे में एंड दिस इज एन ऐप प्रैक्टिस सेक्शन। इसीलिए मेरे बगल में यहाँ पे आपको ऐप का स्क्रीनशॉट दिख रहा है। दिस इज द आकाश बायजूस ऐप फॉर जेईई एंड नीट। हम लोग नीट चैनल पे हैं और ये प्रैक्टिस नीट वाले कोहोर्ट की होगी। सो अगर आप स्टूडेंट हो एंड इफ यू डाउनलोड द ऐप एंड यू सेलेक्ट नीट, मे बी यूल गेट सिमिलर क्वेश्चन, बट सवाल बहुत ढेर सारे हैं और एक लॉजिक के साथ आते हैं। विल डू ऑल ऑफ दैट, ठीक है। खुद ट्राई करके देखेंगे। सो आई हैव नो आइडिया व्हाट काइंड ऑफ क्वेश्चन विल कम, यू नो द ड्रिल। These are the different stages. हर स्टेज में पांच पांच सवाल होते हैं. Just giving you a quick rundown of what we're going to do. वार्म अप, स्ट्राइड, स्प्रिंट, लैप्स, रेस एंड फिर मैराथन. यहाँ पे अनलिमिटेड क्वेश्चन है. हम लोग साथ में सवाल सॉल्व करेंगे. I'll show you the question on the screen and उसके बाद आप देखिए, give me responses and we'll take it from there. We'll see क्या होगा. If we keep answering a lot of questions correctly, the questions are going to get a little bit harder. If you're wondering what this is, देखो, come out of this, I'll go right to the basics. You go here, this is the app, go to the chemistry section and then go to kinetics and here we go. यहाँ पे है प्रैक्टिस, ठीक है. ऑल्सो आपको अभी सेशन में ऐप कुछ डाउनलोड करने की जरूरत नहीं है. आई एम जस्ट शोइंग यू द ऐप. यू कैन पार्टिसिपेट. दैट्स ऑल वी वांट फ्रॉम यू, जस्ट लाइक इन अ रेगुलर क्लास. एंड बीच में हम लोग नॉर्मल से क्वेश्चन भी करते रहेंगे. किस चीज पे? केमिकल किनेटिक्स पे. तो शैल वी गेट स्टार्टेड? शुरू करें हम लोग. मेरी आवाज साफ आ रही है? आर यू एबल टू हियर मी एंड सी मी क्लियरली? इज दैट ओके? प्लीज लेट मी नो इन द चैट. ऑलराइट, जस्ट गिव मी अ थम्स अप इफ दैट्स गुड. सो पहला सवाल, लेट्स गेट दैट आउट ऑफ द वे. पहला सवाल is this right here. Yeah, regular सवाल, just like we normally do things, just to get you warmed up. उसके बाद we'll go back to the app and look at this. Yeah, every 5 questions we'll come back to this and we'll do that. चलो, okay, simple सा question है. इस reaction के लिए A plus B giving C plus D, if you double the concentration of दोनों reactant, तो एक को डबल करने की वजह से रिएक्शन रेट 4 गुना हो जाता है, 4 टाइम्स, एंड दूसरे वाले को करने की वजह से रेट में कोई फर्क नहीं पड़ता है. रेट लॉ फाइनल क्या होगा? सो इफ यू राइट दिस डाउन, I'll keep talking about the process. If you know the answer, please check it out. Hi Rajanya, I'm good. How are you doing? How you doing? Good to see you here. So if you know the process, please go ahead and start doing it. If you would like me to help, as always, I'll tell you यहाँ पे करना क्या है. The rate law would be given to be K, A par X, B par Y, right? Okay, cool. Now they're saying that A dash, if A dash is equal to, how do we write this? A dash, yeah, okay, cool. Or is it okay? ठीक है. A dash is equal to 2 times A, right? Then rate basically R dash becomes 4 times R. Okay, that's interesting. और अगर B dash को हम लोग करें 2 गुना, तो फिर R dash is equal to R, मतलब रेट पे कोई फर्क नहीं पड़ता है. That's what we are saying. Okay, so can we figure this out? I'm good, Rajan. How are you doing? So if I tell you this, यहाँ से can you get to the answer? देखो, since let's do the easy one first. Since rate में कोई फर्क नहीं पड़ रहा है concentration बदलने से, so I feel that y should be equal to 0. मतलब कि B हो या ना हो, well obviously है, reaction में participate कर रहा है, but B की concentration पे रेट लॉ पे कोई फर्क नहीं पड़ रहा है. मैं एक करूं, डबल करूं, तीन करूं, does not matter. That's possible only if this power y is 0. ठीक है? You can also put the maths around this and see this. But that's the easiest thing that comes to my mind. What about this second one? अच्छा, इसको 2 गुना करो, 2 गुना करो, 4 गुना हो गया. So 2 par 2 is equal to 4. So A का order is going to be square. Hence the overall order is going to be C मेरे हिसाब से. Yeah, Rajan, absolutely. Hi Mehak, how are you doing? Hi, good evening. I think it should be C as well. If you want to go through the motions, we can do that, right? हम लोग इसको धीरे धीरे करके आराम से कर भी सकते हैं, right? All I have to do is substitute this over here. So I'm going to write down here कि R dash is K 2A, which basically power X is equal to K times A, right? So then you get R dash to be equal to 4R, right? इस केस में I'm examining case 1. मैंने तो जल्दी से करके आपको बता दिया, बट अगर आपको लग रहा है कि बहुत जल्दी वो एक्सपोनेंट्स का आदत नहीं है, so what do you do here? So you write here 4R is equal to K into A power 2x. ठीक है? B तो constant है, तो it doesn't matter. So divide both of these things, right? And you get that, okay, well, 2 power x A power 2x नहीं होगा, it will be 2 power x. A power x into, well, A तो हट जाएगा, right? All I have to do is I have to divide this and this, yeah? So if I have 1 and if say, let's put this one as 1, make this one as 2, If you do 2 divided by 1, basically divide both these equations, you get 2 power x equal to 4. That's what I was trying to say. ठीक है, उससे आपको मिलता है कि x must be equal to 2. This is going behind me, but you get the gist of this. Simple one, very easy, right, Anshita? Yeah, very simple question. All right, let's look at the app then. ये आपको अच्छा लगा, simple लगा, that's great. मतलब yeah, I think that's sufficiently warmed up. Let's go see what the app says. Okay, so right off the bat, is it possible to have a reaction where the rate of the reaction increases but the rate constant decreases? अच्छा, इसका क्या मतलब हुआ? Is it possible to have a reaction where the rate of the reaction increases but the rate constant decreases? ऐसा हो सकता है क्या? आपको क्या लगता है? I haven't seen this question before ever, right? I'm seeing it with you for the first time. So let's analyze this together. मतलब क्या होगा इसका आंसर? Okay, अगर इसका hold on, let me put this on this thing so I can also see it clearly. This screen goes off, okay? So I have to see it with you over here. My phone screen goes off because it's screen sharing. Yeah, it's weird. Anyway, okay. Rate of the reaction increases, but the rate constant decreases. Rate constant decrease होगा temperature कम करने पे. That's the only thing I can think of, right? Rate constant depends only on temperature, nothing else really. Also on collision and all of that. ठीक है. But broadly सोचो तो temperature कम करने से हो सकता है. Rate बढ़ जाएगा. I don't know. I don't think this is possible. What do you think? आपको मुझे पढ़ने से लग रहा है तो possible नहीं होगा. But आपका क्या सोचना है? Whatever you say, we will, you know, we will mark that. I feel that it's not possible. I think this is false, right? Hi Maran, how are you doing? Rajan is saying false. All right, I'll mark false. Good job, good job. Yeah. So अगर k की वैल्यू ज्यादा होगी तो फास्ट होगा. And also this did not make too much sense, so it must be false. Absolutely. ठीक है, cool. Next वाले पे जाते हैं. Graph between concentration of product X and time t for something is given below. अच्छा, graph आने में थोड़ा time लगा. Okay, the graph between. Okay, so पहला वाला graph is the integrated law. The second one is the differential rate law. ठीक है, उसके बीच में दोनों के बीच में पूछ रहे हैं क्या होगा. This one's interesting. ये वाला मजेदार सवाल है. Let me put this onto your screen as well. I mean, you're able to see this. We'll scroll and look at the options. Let me put it onto the slides because इसके बाद you will get access to these slides, right? Notes and all that. उसके लिए I'm just preparing you for it. Hold on. और थोड़ा नीचे किया जाए ताकि we see all the other options. A और B उस समय A और B दिख रहा था क्या? नहीं, just A दिख रहा था. Okay. Let's take this one. Let's take this screen now. So पहला था integrated rate law and this is differential rate law. Are you able to see that? That's like the key idea to start with. देखो, this is one of those questions where you have to think कि भाई इसको शुरुआत कहाँ से की जाए इस सवाल को, right? If you've got that figured out, I think kind of उसके बाद हम we can work with things. ठीक है, तो पहले दिया हुआ है कि प्रोडक्ट, एक मिनट, ये कहाँ आ गया? इधर नहीं, इधर. This is false. Okay, ignore this. Let's go to the next slide. Okay, here. Okay, so straight line graph of x versus t. Okay, cool. Concentration x versus t. Minus dA by dt versus t का क्या होगा? Okay, so technically let's take it as a versus t, no, by x. Let's write it as a versus t. So if a versus t is an increasing straight line function, that means that a okay, a naught must be 0, then no, that doesn't make any sense. अच्छा, इसमें this is a product, that means that this is a product, right? Graph between concentration of product x and time t for a giving b. So this is not a, this is actually b, है ना, क्योंकि ये बढ़ रहा है, अदरवाइज a की कॉन्सेंट्रेशन कम होती, तो ठीक है, ये concentration of b versus t हो गया actually. Okay, cool. So it starts with 0 and increases, and it's a, yeah, so I feel that maybe this could be the relationship a naught minus a equal to kt, because it's a straight line, right? ये है product का, ठीक है, product will be just equal to b is equal to kt. हम लोग, I know we don't talk about product, we generally talk about reactants, so इसलिए थोड़ा confusing हो सकता है, but this is what it looks like. Is this okay? Yeah, I have figured out that it is this because of this. Is this part okay? This one's an interesting question. Absolutely, Bibhaji, why not? Sure. Rajan, you have done this before. Make sense is B. Make को लगता है B है. Okay, let's see. B. Okay, ठीक है. देखो, minus dA by dt. Okay. I feel integrate करने के बाद it's a straight line. मतलब डिफरेंशियल रेट इक्वेशन में कोई भी a की वैल्यू नहीं है. ओके, आई टेल यू व्हाट आई मीन. माइनस डी ए बाई डी टी इज इक्वल टू के ए पावर एक्स. दैट्स व्हाट यू गो विथ, राइट? ओके, मैं ये बोल रहा हूं कि x मस्ट बी इक्वल टू 0. Why? Because only then on integrating this you get this equation. Do you follow what I'm saying? Do you understand this? इसकी वजह से I feel it should be C. I don't know. मतलब just from what I've seen so far. I'm going to repeat everything I said. देखो, ये जो रिएक्शन है, I mean ये जो क्या बोलते हैं इसको, रेट का हम लोग को ग्राफ दिया गया है. फर्स्टली दिस इज द इंटीग्रेटेड लॉ. ठीक है? And it looks like it's clear कि as time increases, concentration of B increases linearly. मतलब कि concentration of A must also reduce linearly. अब अगर linear होगा, then this is the equation. ये हो गया linear equation of the integrated rate law. इसको differentiate करो. Differentiate करो तो you will get. If I differentiate this for that matter, let's do that. No, let us do d by dt of this expression जो मैंने यहाँ पे लिखा है. Okay, let's also do d by dt of this. This is very straightforward. This will become 0. This will just be minus dA by dt. ठीक है? So you get minus dA by dt is equal to k. ठीक है? Which कौन सा, अब if I say this, अगर मैं ये दिखाऊं आपको तो कौन सा ये मार्क करेगा? So this from me marks with option C. What do you think? क्या लगता है आपको? ज्यादा हो गया? भारी सवाल in the starting. भारी in the sense कि because people don't usually talk about the product. इसलिए मे भी थोड़ा भारी. Otherwise it's not that difficult to anything. You just have to do this from first principles. ठीक है? ये है प्रोडक्ट की बातें और ये है रिएक्टेंट की बातें. तो बिकॉज मैंने कुछ सवाल सॉल्व किए हैं जनरली इन लाइफ, सो आई कुड काइंड ऑफ गेट की लुक, आई कुड गेट टू दिस राइट वे. बट इवन इफ यू गो इन डिटेल एंड यू गो विद दिस एंड यू डिफरेंशिएट, यू गेट द सेम थिंग, सेम चीज मिलता है. ठीक है? इट्स प्रीटी कूल. नाइस क्वेश्चन, नाइस क्वेश्चन. This is a hard one. See, they're appreciating that you got a hard one right. All right, great. सही है, सही है, सही है. मजा आ रहा है यार. सही है. Is this a NEET code? I think it is. This should be the NEET one. Okay. What? What? Okay, I'm going to ignore the dragons burning part. That's a little more morbid. 2C plus CO2. 2C plus O2 gives 2CO2. What is the average rate of this reaction? Average rate of this reaction. I know who made this question. The moment I read, I'm like, yeah, this has a mark of somebody I know. This is the same person who made some of those funny questions in the solutions chapter. Yeah. Okay. So generally, हम लोग जो average rate को बोलते हैं, we take for 1 mole of the product being formed. Now, I could write it as minus, we use the same yellow color, right? I could write this as minus d of O2 by dt, or 1 by 2 d of CO2 by dt, or I could also write it as minus half C d of, पूरा लिखने का स्पेस कम हो रही है, d of C by dt. I can write all of these things. It's the same thing, right? Because it's a product, hence there is no negative sign. And there's a reactant, and you wanted the whole overall thing to be positive, right? Because reactant की quantity कम होती जाती है, तो you put a negative sign to make it positive, the delta part positive. मैंने d लिखा है, अब delta लिखा है, same ही चीज है. So I feel out of all of these, only one answer is correct. Because पहले वाले ऑप्शन में Harry Potter question. I think it's more Game of Thrones, but sure. All right, see, everyone's figured this out. Easy question. Rajanya, Smasher. All right, Smasher, how are you doing? Yeah, could be Harry Potter as well. Sure, that wasn't the guess. देखो यार, ऐप मुझे टॉन्ट कर रहा है. देखो तुम लोग की वजह से मैंने मार्क किया है. Why was it a guess? We spent quite a bit of time on this. All right, good job, everybody. Good job. Next question. PH3. देखो, the thing with this practice is that it is adaptive. Adaptive का मतलब क्या हुआ कि अगर आप क्वेश्चंस अच्छे आंसर करते जाओगे, अच्छे से सही आंसर करते जाओगे, it steps up the difficulty, and that is probably what is happening over here. pH3 on tungsten at low pressure is a first order reaction. Why? Why is pH3 on tungsten? Okay. Okay. This has to do with surface chemistry, to be honest, which is not in your syllabus. But हम लोग इसको यहाँ पे बात कर सकते हैं because it falls into kinetics. What is pH3? pH3 is like NH3, yeah, but well, with phosphorus instead of nitrogen, right? So why would you need pH3 on tungsten? Well, maybe this some sort of organic reactions would require this, yeah. हम लोग अब adsorption की बात कर रहे हैं, ठीक है? AD, adsorption, okay. So what happens is, oh, I think I missed out decomposition. The decomposition, okay, of phosphine. So basically, pH3 is becoming, what is it becoming? P plus H2, B4 plus H2. We are balanced or whatever. It doesn't matter. It's a first order reaction. I'm not sure if this is the right reaction. I'll look it up. I can do that right now. Actually, is this the right reaction? I think this is the right reaction. So the general idea is that this is a gas. That's all you need to know. Like just like ammonia is a gas. So this is a gas. Okay. So since it's a gas and it is being adsorbed on tungsten and it's decomposing, it's a first order reaction. Okay. Now let's look at the options. Rate is proportional to surface coverage. Rate is inversely proportional to surface coverage. Rate is independent of surface coverage. Rate of decomposition is very slow. I think it's the first one. What do you guys think? What do you guys think? आपको क्या लगता है? What do you think? I think it's just the first one. This is not that complicated at all. Yeah. This is an idea of surface chemistry. If you have studied surface chemistry, you'll be like, yeah, this is definitely it. This is definitely it. But if you have skipped surface chemistry, which is fine, right? It's not in your syllabus. It's okay to skip it. This should be the answer to this. It should be A, I think. Yeah. Let's see. Kya hota hai. You guys also saying A? That's great. Oh, great. Okay. It's written as P, but I feel it should be P4 because you write it standard forms. But maybe this is how you write it. Either way. So see here, adsorption में, yeah, this is interesting. Low pressure की बात कर रही है, ठीक है? Is sum alpha times P divided by 1 plus alpha P. So at low, this is very interesting. Okay. If you want to know the graph, थोड़ी सी extra information. This is the low pressure वाला चीज and then it becomes constant. ठीक है? So at high pressure, it becomes constant. Okay. Because high pressure मतलब ज़्यादा concentration, right? Pressure of what? Partial pressure of pH3. It becomes constant because all the sides get filled up. Okay. And initially it's a first order reaction because 1 is much greater than alpha times P. Now this alpha has nothing to do with degree of dissociation. Alpha लिखा है, आप K भी लिख सकते हो, ठीक है? K1, K2 भी होता है. This is how adsorption works. Anyway, let's look at what the app is saying. App भी ऐसा ही कुछ बोल रहा है क्या? P partial pressure, blah blah blah. हाँ, ठीक है, cool. यही चीजें बोल रहा है. At low pressures, right? You ignore that alpha P वाली चीज. बढ़िया है. Nice question. Lovely question actually. बढ़िया सवाल. Calculate rate of disappearance of ammonia. नहीं? अच्छा. I was like, wait, some questions थोड़ा अलग लग रहा है. The scientist Q was experimenting to revive a giant called the Mountain. See, I told you it was Game of Thrones. You could get sued for this. He actually dropped a vial of ammonia on the ground. He saw ammonia react with oxygen and produce NO and water. Okay, I'm going to move this up and focus on the part of the question that's relevant to us. Ammonia reacts with oxygen and to produce NO and water. Okay, NH3 plus O2 gives me NO plus H2O. Okay, great. We have to sit and balance this, I suppose. Yeah, we have to balance this because the question says, let's say the rate of formation of NO, or let's say D NO by dt and 1 by x. We'll find out what that x is. Okay, is 3.6 into 10 power minus 3 mole per second. Okay, great. Calculate the rate of disappearance of ammonia. So we got to find out minus 1 by y. Don't worry about the x, y and all that. हम लोग balance करके निकाल लेंगे. This and also क्या निकालना है? दूसरी चीज, rate of formation of water. Okay, cool. Let's put it as z. 1 by z d H2O by dt. You'll notice कि मैं सब जगह प्लस और माइनस का ध्यान रख रहा हूं because this is a reactant, it is minus, this is product, it is plus. ठीक है, अब इसको बैलेंस किया जाए. The process or approach, I feel, should be that you have to first balance this equation. And once you balance this equation, we can figure out the option. All it's fine. Options देख लेंगे. But इस सवाल में option की वैसे जरूरत है नहीं. Will the options help us in this? Let's see. Do the options, can you eliminate things because of the options? देखते हैं. So first step is to balance this reaction. That's all. That's all. सिर्फ यही करना है इस क्वेश्चन में. Balance किया जाए. थोड़ा सा move कर दूं left में क्या? Is it getting too crowded here? Let's see. Balancing. Let's just put a 2 here and see if that works out. 2 and why did I put a 2 there? Because there was a 3 of hydrogen and that doesn't work. So 6 ho gaya ye. What if I make this a 3? Does that work? 3 now still doesn't work. 2 and you've got now. This works. I guess it kind of works. 5. So I put 5 by 2. Kind of works, right? नाइट्रोजन हो गया बैलेंस. हाँ, सब कुछ बैलेंस हो गया है. Yeah, this works. This works. I could, just to make sure it's perfect, I could also write it as 4NH3. I mean, if you want to be proper about it, just check. Please check if my balancing is correct. Plus gives you 4NO plus 6H2O. Wow, this looks a little wild. 6 4s are 12, 4 3s are 12. Okay, 6 and 4 10, 4NO 4. Yeah, this looks balanced. What do you think? आपको क्या लगता है? Does it look balanced to you? मुझे तो लग रहा है बैलेंस है. आपको क्या लग रहा है? मैं राजन, what do you guys think? I feel it's balanced. After we do this balancing wala business, I've been given कि dNO by dt. Let's say the rate of formation is given to be something. अब मुझे rate of disappearance निकालना है. Looks balanced, okay. अब आगे कर सकते हो. From here, can you do this? Can you do this? इसके बाद कर सकते हो? Yeah, you think it's doable? I think I'm pretty confident now that x should be equal to 4 now. Okay, and y should be equal to, what is y? Y क्या था? NH3 and ammonia should be equal to 2, and z should be equal. यहाँ कोने में लिखते हैं, कहीं अलग से लिखते हैं इसको. It's getting too muddled up. So x is 4, y is 2, and z is 3. Now z is 6, y was NH3, was also 4, x is 4, right? Cool. So from what I get, okay, now let's see if we can eliminate stuff. It looks like to me the number 3.6 should be the same for ammonia as well. Okay, ammonia में rate of formation disappearance of ammonia 3.6. So I can now eliminate options B and C. Why? Because I've got that the rate of disappearance of ammonia, because of the stoichiometric ratio, it's going to be the same. Okay, number wise at least it's going to be the same. So we eliminate as 2 L's, eliminate B and C. Okay, cool. And we also eliminate A because, well, it has to be different. A is also eliminated because water is, 3 by 2 times of this, right? So ये भी हो गया. Yeah, it should be D. Exactly, Rajan. Absolutely, I agree. It should be D. You got the logic, right? You have to calculate it. We can calculate it if you want. All right. Good question. Nice question. Yeah. So the main thing just here was just balancing it. And balancing करने के बाद थोड़ा सा effort लगाना पड़ा. Yeah. 1 by 4, 1 by 5, O2. Yeah. This is exactly what we did. Awesome. But yeah, we're on a roll, huh? We're getting some pretty tricky questions out of the way. And that's it. That was the first thing. We'll do many more. Don't worry. देखते हैं. अभी एक और दूसरा सवाल लेते हैं. Here you go. That was the app, and we're back to a regular question. The more we finish the app stuff, the more we'll get one of these kind of questions. Okay. इस reaction में अगर volume of the reaction vessel is doubled, then what happens to the rate of the reaction? They're all gases. मतलब concentration will be affected. Concentrations affected. And अगर concentration वाला चीज नहीं समझ में आ रही है, then you remember that PV equal to nRT. So P equal to N by VRT. So even if you take things in terms of partial pressure, right, is going to be inversely proportional to volume. That's the most important idea here. So अगर आप volume double कर रहे हो तो partial pressure आधा हो रहा है, concentration भी आधी हो रही है, same ही हो रहा है. Partial pressure अगर आधा हुआ, concentration भी आधी होगी, same thing, right? Does that help? Can you try it out from here? Yeah, Mehak, you guys are absolutely right on that question. What about this one? Can you try this out? What do you think about this? Doable, right? I feel it's doable. The only thing you have to be careful about is this, that is inversely proportional, not directly proportional, right? Uske baad to it's very chill. Because see here, if I were to write it down, right? अगर इसकी concentrations are say whatever, x and y, ठीक है, and volume reaction अगर double हो गया तो it will become x by 2 and y by 2. Cool. I'm talking about NO and O2 concentrations. They can be different. Concentration ले लो, partial pressure ले लो, either way, doesn't matter, right? They will get half. Okay, great. Now अगर ये half हो रहा है, so now rate dash is going to be equal to x by 2 square y by 2. Clearly, it's getting to a factor of 1 by 8. Yeah, this is basically going to be a 1 by 8 factor of 1 by 8 times x square y. And this, with this, you get rate to be some k times x square y. Clearly, yeah. Maths say, now effort लगाने की जरूरत नहीं थी. It's obviously B. But if some students find it to be a little bit difficult, I've shown you the math as well. Simple? Yeah, absolutely. Padhya. Let's resume our practice. And here is your next question. Let's assume you're a student of Arrhenius. He asked you to calculate EA for a reaction. He asked you to calculate, screen. He asked you to calculate EA for a reaction so he can study for a long time. Okay, ठीक है, चलो first scroll करते हैं. Okay. He told you that the rate constant of the reaction at 500 and 700 Kelvin is some different value. Calculate the value of EA. We can do this one. I think we can do this. The numbers are far apart for us to make some sort of approximations. I think option A or C में काफी close हैं. बाकी options are quite far apart. We can maybe make approximation. Let's see. Let's see इसको कैसे करते हैं. Okay, what do we do here? Arrhenius का नाम लिखा है तो जाहिर है कि उसी की equation use करेंगे. We will use Arrhenius equation here. What does Arrhenius equation say? Look, let's go from first principles. आप लोगों, if you know how to do this, please go ahead and try solving it by yourselves. Right? This is it. So you get ln k2 by k1 equal to, well, I'm basically taking log and subtracting both the equations. ठीक है? I'll write that down. Take log, subtract. Okay. And then you get this. What do you get? Minus delta H 1 by T2 minus 1 by T1, which then becomes plus करने से sign बदल जाता है, T1 T2 बदल जाता है. ठीक है. Okay. Now, main thing is that temperature बढ़ाने पे, this is the theory, temperature बढ़ाने पे K must increase. Okay. If you forget, by the way, कि plus sign क्या है, ये सब अगर भूल जाओ तो ये याद रखना बहुत जरूरी बात है और सिंपल सी बात है. टेम्परेचर बढ़ाओगे तो K की वैल्यू बढ़ जाएगी. Okay. This is different from, instead of delta H, I should write EA. Right? This is different from the usual thermodynamic stuff that you see, where you have a dependence on the value of delta H. वो capital K, तो जो मैंने equation लगी capital K की लिखी, this is small k, which is rate constant. Okay, rate constant will always increase with temperature. मैं बार बार बोल रहा हूँ because ये जरूरी है. Because अगर गलती से if you forget what the equation is, you can still figure it out more or less कि अच्छा क्या करना है यहाँ पे. अगर माइनस ए लिख लूँ, T2 क्या था, T2 पे कितना था 0.07 minus 1 by 0.02 और माइनस साइन मैंने एज इट इज लिख लिया. इज एनीबडी हियर इन द चैट गिविंग मी द आंसर? ओके, थोड़ा कैलकुलेशन है, आप भी ट्राई करो, मैं भी ट्राई करता हूँ. आई टेल यू क्विक वे ऑफ डूइंग दिस एनीवे. और क्या था, डू आई नीड एनीथिंग एल्स? नो, आई डोंट थिंक आई नीड एनीथिंग एल्स. EA by RT था ना? नहीं, वो तो चला गया. EA by R, इट्स नॉट माइनस EA, it's EA by R. Thought I was forgetting something. Okay, cool. What is the value of R? 8.31468, 25 by 3. ठीक है. So EA now will be equal to ln 7 by 5, pretty much that. Let's leave that as it is. ln 7 by 5, whatever that is. इन दोनों का अगर मैं LCM लूं, so I get 7 minus 2, which is 0.05, but वो भी denominator में चला जाएगा. So it is going to be into 0.05 denominator में. Numerator में 0.07 into 0.02. Okay. Have I counted for everything? I have to multiply this whole thing with R. Okay. Now something seems fishy to me over here. Right away, right? फिशी क्या फिशी है? आ, मैंने कुछ उल्टा लिखा है। या आई रियलाइज आई रिटन समथिंग। या तुम लोग बोल क्यों नहीं रहे हो? आई वाज लाइक वेट, आई हैव सब्स्टिट्यूटेड सम वियर्ड स्टफ। यहाँ पे के जाना चाहिए। कम ऑन गाइस, प्लीज डोंट स्लीप। After putting numbers, I'm like, wait, yeah, does not seem like it should be this. Yeah, I'm teaching you through silly errors. Nah, that was an honest goof up by me. Okay, ln 7 by 2. Yeah, I've just fixed everything there. So 0.07 पे 700 पे वो था और 0.02 was at 500. ठीक है. Okay, great. Now this looks so much nicer and neater. R let me write as 25 by 3. लिख लेते हैं 25 by 3 should be okay. From here क्या करें? क्या करें? अब क्या करें? What is ln 7 by 2, dude? I have no idea. Okay, ln 3.5, मतलब little more than 1, I guess. But this is going to get complicated. This looks like it's going to get complicated without a calculator. Can we do it without a calculator? Let's see. 25 goes once, 25 goes 8 times, 200, yeah. 8 times here, and this goes 500 के साथ कितनी बार जाएगा? If I go 6 times, 48, 20 goes 2.5. Okay, not looking good, not looking good. If I divide this by 3, I get 2, 0.8. So let's say 21. Okay, so 21 into 700 into 1 almost, right? 21 into 700 is what I got. 14,700 into like little more than 1. Now see, this is what is getting interesting here. ln 7 by 2. Nah, man, that's a hard one. 18,415. You need a calculator for this. There's no way you're doing this without a calculator. I thought you could, but I think for this question, to be fair, I think you should have the value of what on earth is ln 7 and what on earth is ln 2. Well, okay. Now, if you were to mug these values, I mean, you don't have to, but if you mug these values, ln 3.5 could be taken as, let's see, let's just play around with this. 4 minus 0.5. Okay. ln 4 minus, is this correct? No, that is not correct. No, I don't think you can play around with this anymore. Okay, let's find, let's do this. Let's write as ln 7 minus ln 2. Okay. Log 7 क्या होता है? Log 7. Log 7 is point. No, man, I'm not getting this. You got to use a calculator on this one. You got to use a calculator. But I feel the answer is 18,431 with this calculation that we did. Oh, wow, great. So then it's either 18,231 then. Great. So there you go. The awesomeness that we did. Yeah. So if I don't use this 2.303, I got 18,431. So it's really close. Or मैंने कुछ approximation लिए. You need a calculator for this. That's the moral of the story. Yeah. Okay. Let's go on to the next question. This question needs a calculator. It's hard to do without it. ठीक है. Samuel has to answer. Samuel Tali. This is definitely Game of Thrones again. No copyright strikes, right? I think we can do this. Two final questions to become junior maester. Let's help him. Elementary reactions are so called because they have just two reactants. They take a single step. They give rise to exactly one product. They are the basic reactions of nature. ये वाला simple question है. The moment you mess up on a hard question, it gives you an easy one to, to make sure that you're understanding other stuff. So how the algorithm works is that it'll keep testing you, giving you questions. If you keep answering things correctly, it'll keep increasing the difficulty level and it'll change the concepts. If you mess up a hard question, the next question that you get may not be from the same topic, it may be from a different topic, but it'll be slightly easier. This is what I've seen, okay? And there is an algorithm behind all this as well. What do you think about this? Elementary reaction को कैसे हम लोग figure out करेंगे? Two words. That's it. It's as simple as that. Absolutely right. Well done. Well done. Okay, elementary reaction is something that takes place in one single step. There's simple stuff there. Okay, next one. If half-life period of a first order reaction is 2 minutes, what is the rate constant? A direct question, perhaps NCERT का solved example type भी हो सकता है. It could be like a question that you would, maybe learn while you do it, while you are studying this for the first time. So काफी direct question है, but we can do this. Okay. Half-life period. The main thing is K_T power half is equal to ln 2, right? The half-life is not dependent on concentration. It's independent of everything else, which is why इट्स सेइंग दैट अगर मैंने हाफ लाइफ दिया है तो उसे रेट कांस्टेंट निकाल सकते हैं. सो आई विल हैव टू डू इज जस्ट डू दिस is 0.693 divided by 2. Is that correct? Yeah, I think this is it, which is 0.346 minute inverse. I feel it should be that. Yeah, see that, right? Not complicated at all. Very easy question. Shall we move on with this? Are you guys satisfied with this? Yeah? Yeah, all right. Lovely. Agla sawal. Higher order greater than 3. Yeah, this is nice. This is a great question. Why is it that higher order reactions, मतलब 3 से ज़्यादा, are rare? They almost practically don't happen. Like हमको पढ़ाया जाता है कि यार order can never be greater than 3, right? That's a general thing that's taught. Molecularity at least cannot be, order की बात नहीं करते. Molecularity cannot be greater than 3. क्यों? Why is it? Smasher is on fire. Huh? Low probability of simultaneous collision of all the reacting species. Pranam Narayan Das ji. Increase in entropy and activation energy as more molecules are involved. Shifting of equilibrium towards reactants towards elastic collision. Lots of factors. Yeah, you're right. There's a low probability of simultaneous collision, and also collision हो भी गया तो effective collision होना चाहिए. They should collide with enough energy and at the right orientation. ठीक है? There are many things involved in reactions actually happening, right? If you think about all this, you're like, given all this, reaction will probably never happen, right? अगर इतना करना है कि भाई they have to come with the right orientation, they have to, and with enough energy for a successful collision to happen. So that's the real idea, right? So if you go through statistics and all, everything is explained in terms of probability when you take a lot of stuff, Maxwell distribution, all that. All right, great. All right. Nice. Well done, Smasher साहब. एक और question on rate of formation and rate of disappearance and all of that. Here you go. Please try it out. एक second. And here, copy paste it. For the reaction something, the value of rate of disappearance is given as something, rate of formation of this and that क्या होगा. अभी यहाँ पे the main thing that I see is कि N2O5 and NO2 का number should be the same, correct? And oxygen forms slower or faster? I feel oxygen forms slower, है ना? Slower. Just by looking at the numbers. देखो, for 2 moles of N2O5 being reacted, just 1 mole of oxygen will get formed. So oxygen should be half without writing any numbers. कोई जरूरत नहीं. If you want, we'll do that. But I feel that's not necessary in this question. So 6.25 and अच्छा ठीक है पूरा दिखने का option. Sorry. So 6.25 and half of 6.25. That should be the value, right? So I feel it should be C. This is the only option that has 6.25 and half of 6.25. Okay, I'm going to write down those words here. N2O5 is going to be equal to D of NO2 by dt minus plus and all of that, and this is going to be equal to, oops, what's happening? Sorry. I thought I was not getting this. इन दोनों का इक्वल हो जाएगा, ठीक है, एंड इसका हो जाएगा, well, technically I should be doing that. They both are equal, and this is going to be half of that of T of O2 by dt, right? Because if I balance this reaction, let me switch over to my screen so you can see this clearer. I've taken screenshots of this. If I balance this reaction, I put a 2 here, I put a 2 here, and I scratch off that, right? That's how I've gotten this thing over here. Okay, cool. So oxygen will be half because of this, and you don't even need this equation to justify this. Just from looking at the moles being transferred here, you clearly can see this is the idea. Hence, I feel it should be C. आपको क्या लगता है? सूरत बिल्कुल सही. Smasher भाई साहब, yes, exactly. C it is. अरे B मैंने मार्क कर दिया क्या? अरे यार माफ करना, हम लोग इतना C बोले और गलती से मैंने B मार्क कर दिया. खैर, no, this was correct. Moral of the story: the most important thing of any test is to mark the right option. ठीक है, आपने सब कुछ सही कर दिया. Anyway, this is not going to happen to you in a test, because test में you have the options of changing questions. Even if NEET goes online, it's not like आपने mark कर दिया तो submit हो गया, right? You can always change things up. But इस practice में ऐसा नहीं है. Test में BYJU'S के test में ऐसा होता है, you can change options. प्रैक्टिस में एक बार मार्क कर दिया तो कर दिया. I feel sad though. We got that correct. Anyway, होता है, doesn't matter. Let's go to this question. Next one. This is an awesome question. This is an awesome question. In a certain reaction, yeah, thank you for the. Yeah, in a certain reaction, 10% of the reactant decomposes in 1 hour, 20% in 2 hours, 30% in 3 hours, and so on. What is the dimension of rate constant? ये चीज मैंने पढ़ाई थी अपनी थ्योरी में. It is pretty awesome. I mean, if you already know this, that's great. But this was a small detail that I compared some order reactions. हमारे syllabus में 0, 1 और 2 ही है. Practically 0, 1 है, 2 भी ज़्यादा नहीं है. There were some things I told you about these 0, 1 and second order reactions in my sessions, theory sessions. This is one of those things that you can figure out mathematically. अगर वो नहीं किया है, प्रणाम कन्हैया जी, अगर वो नहीं भी किया है, इसके साथ सवाल के साथ भी we can still solve it. Please try it out. आप भी try करो, मैं आपको बताता हूँ क्या है. I know the answer because I've taught it, right? But even if you don't know, you can still figure it out. Okay, let's see क्या करते हैं. What does this mean? What does this mean? What do you think? How do we start this question? शुरू कैसे करें इसको? Any inputs? Any inputs on how to start this question? Anything is welcome. Whatever comes to your mind. There are no wrong answers as such here. ठीक है? जो आपको ठीक लगता है कि इसको शुरू कैसे किया जाए. Okay. So Smasher says R inverse. मतलब उसके हिसाब से था first order reaction. Correct? Is that correct? राजू को लग रहा है मुश्किल है सवाल. ठीक है राजू भाई. Don't worry. What do you think? How did you get to this first order? Can you tell me? If you tell me that, I'll help you maybe get to a point where okay, let's see analyze कैसे किया जाए. हाँ तो आपने कैसे बोला कि first order होगा? What was the logic behind it? मुझे बता सकते हैं? देखो, if you take थोड़ा सा मैथ्स लगाए ना मजा आ जाएगा. थोड़ा सा मैथ्स. What does this mean? Let's plot this on a graph. Okay. Let's say this starts here. Okay, this is A0. ठीक है. और इस यहाँ पे हो गया 10%, यहाँ हो गया 20%, यहाँ हो गया 30%. अब ये ठीक है. Let's do it properly. 10%, 20%, 30%. ठीक है. So this is 10%, this is 20%, this is 30%. कम हो रहा है. ठीक है. And you have 4, 5, 6, 7, 8, 9, 10, whatever. सारे मैंने मार्क कर दिया यहाँ पे. Okay. So 10% decomposes in 1 hour. Okay. What does this mean? यहां से यहां पे गए, इतना टाइम हो गया 1 hour. Okay. Then यहां से और आगे गए, exactly उतना ही, तो हो गया एक और 1 hour. Then you go from here to here, एक और हो गया 1 hour. What this means is that you've got a straight line. Okay. Straight line of what? When I'm plotting A, not A0, I'm plotting A versus T. I'm not plotting A0, mind you. I'm plotting A versus T. A0 was the initial concentration. What is this? This is A and this is time T. समझ में आ रहा है मैं क्या बोल रहा हूं? देखो 10% decompose हुआ, ठीक है, as compared to A0, 20% as compared to A0, 30% as compared to A0. But what are we measuring? We are measuring A key value, concentration of A. So if concentration of A versus time is a straight line, then, and this has got some A0 value, right? So it becomes A0 minus A is equal to A times T. If I differentiate this, मैंने just अभी किया था, we get minus dA by dt is equal to K. This means this is a zero order reaction. देखो हम लोग मैथ से भी कर सकते हैं. That's why I really like kinetics, right? Even if you don't know anything, आपको सब कुछ भूल गए, आपको बस बेसिक्स मालूम है, you can solve any question in kinetics, any question, है ना? जीरो ऑर्डर रिएक्शन है. और अगर जीरो ऑर्डर रिएक्शन है तो K की यूनिट क्या होगी? K unit is going to be same as dA by dt, which is exactly जो कन्हैया ने बोला, which is zero order, है ना? एक सेकेंड. Yeah. Mole per liter and per second also. So mole per liter per second. So it should be option B. मेरे हिसाब से होना चाहिए. आपको क्या लगता है? राजू समझ में आया? Smasher, you good? Not sure, गलत चीज लगा दी. हाँ, ये जरूरी है, बिकॉज नेगेटिव मार्किंग होती है ना, कोई भी रैंडम चीज मार्क बिल्कुल नहीं करनी चाहिए. It's okay, like even in my sessions, there is nothing at stake, but You can say not sure. You don't necessarily have to say A, B, C or D. बोलो कि यार समझ में नहीं आ रहा क्या करना है. That's absolutely fine. This is a learning experience. Although हम लोग practice कर रहे हैं. देखो दो पहलू होते हैं एग्जाम प्रेप के. एक तो पढ़ाई करना, लर्निंग, दूसरा है जो है सवाल सॉल्व करने में कैसे करना चाहिए, दैट. So we are doing the second part right now. So it's okay. और दोनों की ट्रेनिंग अलग अलग टाइप की होती है. ठीक है, कूल. Nice. B is the answer to this one. Okay, let's go back to the app. अगला वाला सेशन, अगला वाला करेंगे लोग. Sprint. Resume practice. Which of these elements is true in case of reversible elementary reaction? तो भारी सवाल हो गया भाई. What is a reversible? किसको मालूम है क्या? ये reversible elementary reaction क्या होता है? हाँ? मालूम है क्या? Have you heard of this sort of a thing? Is this something you've, like, I don't know. That's new to me. Have you heard of it? We'll analyze. Don't worry. फिर भी analyze करेंगे. Yeah. What do you think? Okay. Elementary reaction जो reversible है. Where have you seen this? आपने देखे होंगे कुछ रिएक्शन जिसमें 2-3 स्टेप्स होते हैं और उसका आपको ऑर्डर निकालना पड़ता है. उसमें से एक स्टेप स्लो होता है, एक स्टेप और बाकी स्टेप फास्ट होते हैं. तो स्लोएस्ट स्टेप का ऑर्डर एलिमेंट्री का इज द ऑर्डर ऑफ द ओवरऑल रिएक्शन. बट कुछ अगर एक और स्टेप है दैट इज रिवर्सिबल, उसका क्या मतलब होगा? व्हाट डू वी डू विद दिस? एनी आइडिया? क्या करें इसका? एनी इनपुट्स? होल्ड ऑन, मैं चैट एक बार चेक करता हूं. आई एम जस्ट पुटिंग दिस क्वेश्चन ऑन टू the whoops, hold on. Too many tabs. Okay, Raju, all good? Okay, ठीक है. अब देखते हैं इसको. Are true in the case of reversible. Rate of forward reaction always very large. Okay. Rate of backward reaction very slow in the end. Okay. Rate of forward reaction very large in the beginning. Rate of backward reaction very slow in the beginning. Look, the rate of forward reaction is going to be very high. That is the case for any reaction. Now it doesn't matter elementary हो या ना हो. ठीक है. Rate. अभी तक हम लोग क्या कर रहे थे? We were plotting A versus T. That was the integrated rate law. Okay. Minus dA by dt अगर if I plot versus T, that is plotting rate versus time. This is the differential rate law. Okay. So, अगर हम लोग इसको ऐसे प्लॉट करें, we are trying to say, have you seen these kind of graphs? इस टाइप के ग्राफ देखिए आपने. If I take a reactant, you will see कि उसका always reactant slope is high initially and then it kind of flattens out. What is this? This is where equilibrium is attained. Yeah, ये backward rate हो गया. Oops. ये forward rate हो गया. When both the rates are equal, that is equilibrium, etc., etc. So, yeah, what do you think? But this is the case for general reactions. Elementary का क्या मतलब? Elementary मतलब कि it goes forward. This is a little bit tricky. I feel that हम लोग इसको kind of skip कर सकते हैं. The general theory is that the rate is very large. C और D दोनों होने चाहिए. Yeah, I feel so too, Smash. That's what I was going to say. Let's skip it. I feel it should be C and D as well. Rate of reaction slow in the beginning and the rate of reaction is high. Reaction won't proceed at all. Yeah, you're right. So it should be C and D both. मुझे भी इसलिए लग रहा था कि we should skip it. It should be very large at the beginning and rate of it should be very low at the end. Yeah. Oops. Yeah. दोनों होना चाहिए. Okay. This is saying that only rate of backward reaction is very slow, but I think it should be both. I'm going to submit this question to my friends and say कि इसको भाई इस सवाल को disable कर दो maybe or make it into multiple correct. I don't know if they can convert a single correct to a multiple correct, but let me just ping them कि भाई इसको बदलना है. 1 second, huh? This Q can be removed or made multi-correct. Both C and D are correct. All right, cool. All right, ठीक है. Let's move on to the next question. Plots showing variation of rate constant small k with temperature T are given below. The plot that follows Arrhenius equation is what? This is testing basics. I like it. I like all questions that test basics. K versus T. Okay, ठीक है. Plot that follows Arrhenius equation. Let's just take a screenshot of that. I'll show you the others. Don't worry. I'm just screenshotting it side by side. That clickety clack is the keyboard that you hear. I don't know if you can hear it. Pretty sure you can hear it. It's loud. One second. Okay, I've got options A and B. Let me get options C and D. One thing I understand is that it's a exponential decay होना चाहिए, है ना? टेम्परेचर के साथ K तो बढ़ना चाहिए भाई. That's also true. यार टेम्परेचर K तो बढ़ना चाहिए. But what is this exponential decay वाला business that we had? I'll write down so it makes more sense. One second. We was bring to front. I'm just fixing the. Okay, this is good. Done. Okay. Okay. So now you may be tempted to mark C, but please don't do that. Okay. But it is only A or B that's possible. It cannot be C or D. क्यों? क्योंकि K increases with increasing temperature. इसमें कोई doubt नहीं होना चाहिए लाइफ में. ठीक है. K equal to A e power minus EA by RT. Look at this. There is a negative sign on E, but there's also T denominator में, है ना? So if you plot K versus 1 by T, right, that would have a slope that looks like this. All right. But if you're plotting K versus T, तो obviously वो तो बढ़ेगा ही ना, है ना? There is no doubt. There should be zero doubt there. ठीक है? Is this okay? Yes? No? Maybe? सोचो इसके बारे में. It's like saying I have e power minus 1 by x. That becomes e power x, no? Is this becoming e power x? Let me think. Is the math off? Exponents. Exponents, people help me. I think it will be e power. No, hold on. Yeah, that was bad math. But basically, yeah. This part is fine. This part works fine. Yeah. If it's k versus 1 by t, it looks like this, where you're plotting 1 by t here and k here. But if it's K versus T, it should be A. It should be A. Yeah, 1, which is option A. Let's go for this. Lovely. A catalyst is used. Catalyst ka bhi solve. I think we have covered the whole chapter, man, with this question, the catalyst question. I think pura chapter cover ho gaya. A catalyst is used only for increasing rate of reaction, for altering rate of reaction, for decreasing rate, for making gives to energy positive. Last wala thoda googly wala sawal tha. What do you think? This is a straightforward question. Like, you should get it right in your sleep. 15 seconds, mark and move on. Right? Yeah, exactly. Altering. It can either increase or decrease. Catalyst poison भी होते हैं. PD, palladium is poison with BSO4 ताकि वह ज़्यादा reduce ना कर दे, थोड़ा reduce करे ना होता है. So you know this, right? It could be positive catalyst, negative catalyst, inhibitor, 10 चीज होती हैं. चलो. For an endothermic reaction, energy of activation and enthalpy of reaction both are in kilojoule per mole. What is the minimum value of EA? Oh, endothermic. I was like, hey, how do you solve this? They've given an endothermic. Nice touch. Without that, it would be a little bit tricky. Now we're stepping it up. This is stepping up the difficulty a little bit. थोड़ा difficulty बढ़ा रहा है. Endothermic reaction. When I get a question like this, I immediately go and draw a graph. किस type का graph? Where we're plotting Q versus say energy, right? Yeah, that's all right. Let's write. Fine, whatever. H, right? Okay. Is this correct? No. Delta H is endothermic, right? You'll see why I did it like this. It says here, this is delta H product. This is delta H reactants, right? This is positive. इसलिए मैंने ऐसे लिखा है. ठीक है? Final minus initial. Final value is higher than the initial value, right? Delta H product is greater than delta H reactant. इसीलिए you get delta H भी positive. इसलिए मैंने ऐसे बनाया. ठीक है. और क्या चाहिए? EA किस चीज का? Let's take EA of the positive reaction, of the forward reaction. पूरा लिख देते ताकि बाद में कोई देखे तो उसको समझ आ जाए. Okay. Let's take the EA of the forward reaction. Goes from here to here. This is EA forward reaction. Okay, cool. अब ये पूरा मैंने setup बना दिया. नाउ लेट मी सी कमेंट से किसी ने कुछ बोला है क्या? ऑलराइट, राजू वाज सेइंग बी पिछले वाले में. राजू शुड हैव बीन 1. आई थिंक, आई होप यू अंडरस्टैंड क्यों इट वाज 1 and not B. B was straight line. Straight line तो नहीं होगा ना. It is exponentially increasing. E लिखा है तो it cannot be a straight line, Raju. Hence it should be A. For this one, what do you think about this one? Endothermic reaction. Energy of activation, enthalpy are positive. Okay. What is the minimum value of EA? Minimum value of EA. I think it has to be greater than delta H. Greater than. हाँ मैं समझ गया राजू, समझ गया मैं राजू. मुझे लगता है it should be greater than delta H. Look at this. EA has to be greater than delta H. Only then this works out. Right? Right? What do you think? Equal to delta H. Minimum value. Minimum value. Well, it could be equal to delta H, but that's pushing it. If it were equal to delta H, that would say ki, this is it. This is the reactant, right? It doesn't go. This is the product. So I don't think it's equal. I think it should be a little bit higher than, a little bit more than delta H. What do you think? Yeah? Shall we mark this? और आपको क्या लगता है? लेस करें, ग्रेटर देन करें, इक्वल करें? I'll leave this one to you. आप मुझे थोड़ा इनपुट तो दो. Mac, Raju, if Smasher's around, Kanaiya's around, and Rajan as well. I feel it should be more. What up? You see the logic, right? Well, let's read this. क्या लिखा है? Yeah, look at that. We do the same thing here. Makes sense. Makes sense. It's not rocket science, है ना? हम लोग को यही करना था कि delta H. You should be able to do this. This is going to be for slightly harder questions in NEET, if this sort of thing comes, right? But main idea है कि endothermic मतलब products are at a higher energy than the reactants. That's why I drew it like this. Activation energy और भी ज़्यादा होगा. हम लोग forward direction की activation energy की बात कर रहे हैं. Yeah, exactly. For forward, it's assuming that. Yeah, बिल्कुल सही. Okay. Samuel. एक बंदा बोला रेट कांस्टेंट इज कैरेक्टरिस्टिक ऑफ अ रिएक्शन. दूसरा बंदा बोला रेट कांस्टेंट इज डिपेंडेंट ऑन टेम्परेचर. तीसरा बंदा बोला रेट कांस्टेंट इज नॉट डिपेंडेंट ऑन कैटलिस्ट. वन वाज राइट, टू वर राइट, थ्री वाज राइट, नन वर राइट. क्या लगता है? क्लियर? ओके, गुड जॉब राजू. व्हाट अबाउट दिस? क्या लगता है इसके बारे में? You have to figure out how many of these statements are true basically. But it looks like only one of them is true, which makes things interesting. मुझे लग रहा है एक से ज्यादा सही हो सकता है. आपको क्या लग रहा है? Let's see. Rate constant is characteristic of a reaction. Okay, ठीक है. Rate constant dependent on temperature. 2 तो definitely सही है भाई. 2 is correct. Rate constant is dependent on temperature. 3 said rate constant is not dependent on catalyst. That is not true. That is not true. Rate constant does depend on catalyst, right? Catalyst से rate बढ़ जाता है या घट जाता है. 3 is wrong. Yeah, 3 is wrong. 2 is right. मतलब that must be the answer. What about 1? Why is 1 wrong? Rate constant is characteristic of a reaction. I mean, two different reactions would have the same rate constant. So I don't know if it's a characteristic. That doesn't make any sense. Characteristic. पहला वाला का मैं अंग्रेजी इतना नहीं समझ पाया, so I will mark it as wrong. And also because only one correct, I know for sure that 2 is right. Rate constant is dependent on temperature. So 2, if there's single correct, then 2 must be right. That's my logic for this one. Okay, so I'm going to mark this, yeah, from the video. Achha, there's a video before this. That's why it's there. Okay, ठीक है. Oh, wow, great. 1 is true, so 2 is true. Yeah, I think I'll remove this question as well from practice. Yeah, right? This question should not be here. इसको भी हटा देते हैं, रुको. Let me tell my friends. Yeah, this question, it's a bit off. The question गड़बड़ लग रहा है मुझे. रुको, हटा देते हैं इसको. Let's remove this Q. Okay. If we can. Or make multi-correct 1 and 2 correct. सही है. हाँ, ये कर सकते हैं. उन्होंने कर दिया. चलिए. अच्छा, इसको हाँ 1 2 राइट एग्जैक्टली करना है. मुझे भी लग रहा था कि स्मैशर 2 तो सही है ना. 2 हैज टू बी करेक्ट. इवन आई थॉट इट्स 1 and 2 आर बोथ राइट. दैट्स व्हाट आई वाज थिंकिंग. एनीवे, ऑसम. एक और सवाल देख लें. वी हैव सम टाइम. लेट्स टेक वन मोर क्वेश्चन. Rate of a reaction A given A plus 2B gives product is something. अगर B बहुत ज्यादा ले लिया गया तो ऑर्डर क्या होगा रिएक्शन का? What do you think? Looks like it's an elementary reaction because a plus 2b और बता रहे हैं कि rate is k b square into a. Yeah, very good. बिल्कुल तुरंत बताते हुए. Makes sense. अगर इसको excess ले लिया, which means the concentration of B does not change. That's what it means. Concentration does not change. If it does not change, then delta of B's by dt is going to be 0, right? That's what we are saying. अगर ये है, which means कि you take कि ठीक है, B power 0 हो जाएगा. Okay, effectively. So it becomes a pseudo first order reaction. Excellent. Easy one. Very easy one. Okay. It's all right, Preetham. Don't worry about it. Yeah. It should be B. All right. How about, shall we do the next थोड़ा और सवाल कर लें क्या? Late थोड़ी ना है. It's okay. We can do a few more questions. Here's this one. Which of the following represents the rate law for this reversible reaction? अरे वाह, अब चीजें थोड़ा इंटरेस्टिंग हो रही हैं. ये है आपका रिएक्शन. ठीक है, इसका रेट निकालना है आपको. So as you keep going ahead, practice, things will keep getting more and more tricky. अगर आपको लग रहा है कि अरे हमारे सेशन में सिर्फ आसान सवाल ही आते हैं, yeah, that's because I do usually the first 3 or 4 sets. I do till laps ज़्यादा मैं normally नहीं करता हूँ because you should have some fun with the app yourself also. आप लोग खुद डाउनलोड करके देखो. You will see that things get complicated as you go on. This is an interesting question. What do you think is the answer to this one? Okay. Which of the following represents rate law for the following reversible reaction? Okay. So if I were to talk about it, right? Forward reaction में A consume हो रहा है, backward reaction में बन रहा है. Right? So let's say it is K1 for forward and K2 for backward. Right? I'll write that here as well. One moment. A, K1, K2. Okay. So if I write minus dA by dt, मतलब अगर मैं इसको कम करना चाहता हूं तो कैसे होगा? K1 times A minus K2 times B. अब this may be a little bit like, what are you doing? Why are you writing minus? Because यार B के कारण बन रहा है, so it should be plus. But since there's a minus here, ये हम लोग यहाँ लिख रहे हैं to be the rate of disappearance of A. इसलिए there's a minus there also. Okay, that's what I feel it should be. Let's see if this matches any of the options. If it does not, we will play around with things a little bit. अरे ये तो पहला ऑप्शन ही मैच हो गया. नहीं, पहला ऑप्शन मैच नहीं हो रहा. तो A is wrong because irrespective whether you talk about B or A, साइन एक का नेगेटिव होगा. अब किसका नेगेटिव होगा डिपेंड्स ऑन व्हाट साइन यू टेक ओवरऑल, बट एक का दे बोथ कैन नॉट बी द सेम साइन. दैट्स फाइन, राइट? बिकॉज K1 एंड K2 आर अपोजिंग, एक फॉरवर्ड एक बैकवर्ड, तो साइन दोनों सेम नहीं हो सकते. जो जहां जहां साइन सेम हम लोग हटा देंगे. चलो उसको हटा दिया, बाकी क्या करें? अब यही सेम चीज आई कैन राइट फॉर B. द डिफरेंस विल बी दैट दिस विल बी K2 times B minus K1 times A. Okay. K2 times B minus K1 times A. तो इस हिसाब से C भी गलत हो गया, है ना? C भी गलत हो गया. ओके, अब क्या करें? अब क्या करें? Oh, we have D. Hold on. Are C and D the same? Good Lord, C and D are the same. Brilliant. So it looks to me like either C or D should be correct. Do you understand the logic over here? जो मैंने लिखा है, ये तो लिखा है तो सही है. अभी इसमें से we have to inky pinky ponky. Let's take a hint, right? The forward and backward reactions proceed at the same time. Therefore, A decreases because conversion to B and increases because of conversion of B back to A. So don't forget to include B. ठीक है, तो ये सब बढ़िया है. That's what we have done. But that means they must have opposing signs. Plus A should be minus K2B. No, उल्टा होना चाहिए. It's either C or D. I don't know which because, well, options are messy. Let's just guess. Because दोनों गलत हैं, it should be plus basically, right? Actual answer होगा plus dB by dt. If you know it's going to be the answer, plus dB by dt will be equal to K1A minus K2B. ठीक है? That's it. So let's mark C. Amazing. हाँ देखो वही आ रहा है, माइनस डी ए बाई डी टी इज प्लस डी बी बाई डी टी विच इज K1A माइनस K2B. वी गेस्ड इट, बट इसमें इसको ठीक करना पड़ेगा. लेट मी सेंड दिस ऑल्सो. बढ़िया QA हो रहा है साइड बाय साइड. वी गॉट लकी विद दैट वन इन टर्म्स ऑफ द ऐप, बट वी हमने जो किया वो बिल्कुल सही किया. दिस वन ऑप्शन C should be plus dB by dt. Cause it is a journey question. Just one sec, huh? Okay, cool. Sorry about that. Let's go to the next question. Which of the following statements regarding a catalyst is not true? Catalyst remains unchanged, composition and quantity at the end of a reaction. Catalyst can alter, gives free energy change. Catalyst does not alter equilibrium reversible reaction. All right. Catalyst sometimes very specific. Yeah, sure. I think it's B. Because we saw this similar question pehle hi. That's why I think it's B. I think it's B. Aapko kya lagta hai? Just looking at it, I think it's B. I'll explain why and all that. It doesn't change delta G value. Because if it changes delta G, it would also affect K. And it does not affect K. That's it, right? That's the simple answer. We can talk about it a little bit more if you want. But basically, catalyst affects Kf and Kb equally. No effect on K slash delta G. So, ये वाला C सही है, catalyst can alter, ये गलत है, ये सही है, सही है. So answer should be B. क्या लगता है? B होना चाहिए ना इसका तो. Very chill. This is B. Yeah. This is just revising what a catalyst does. This is very straightforward. We good? Shall I mark this? I'm feeling something tricky is gonna come up right after this. Spidey senses. Yeah. Awesome. All right. Under the same conditions, the initial concentration of something, of a substance, becomes half, and 20 seconds, 40 seconds and 20 seconds through first order and zero order kinetics respectively. Ratio of blah blah blah, rate constant. Oh, interesting. ठीक है. Same reaction conditions. फर्स्ट ऑर्डर में 40 सेकंड है हाफ लाइफ, जीरो ऑर्डर में 20 सेकंड है हाफ लाइफ. ठीक है. K1 और K0 का आपको निकालना है रेशियो. I told you an interesting question is going to come up because we solved a lot of questions correctly. So interesting question जरूर आएगा. इसमें ट्राई करिए आप प्लीज. This is from NEET. Okay, under the same reaction conditions. ठीक है. अरे इसको मैंने डाला ही नहीं. रुको एक सेकेंड. Let me put it onto the slide so that you have it on the notes. All right, done. Concentration of something becomes half in 40 seconds. Okay, so K1 is equal to 0.693 divided by 40. Okay, that is clear because T half of first order is equal to 40 seconds. T half of zero order is equal to 20 seconds. And I know that T half is equal to A naught by 2K. ये याद है? याद नहीं है तो we can derive quickly, don't worry. How do I know this? You know the drill. Minus dA by dt is equal to K. A power 0. You can write that, doesn't matter. This is just 1. Then I get that A naught minus A equal to KT put A as equal to A naught by 2. So you get A naught by 2 is equal to KT half, which then gives me, whoops, T half to be equal to, ये क्या लिख दिया KT half, which gives me T half to be equal to A naught by 2K, which is what we've written over here. ठीक है? Okay, great. So T half is A naught by 2K. What is A naught? It's 1.386 divided by 2 into K will be equal to, this K0 will be equal to कितना? 20 second. All right, sweet. So K naught is equal to, I hope you guys also trying this जब तक मैं ये सब लिख रहा हूँ. K naught is going to be equal to 1.386 by 40. By 40. Okay, cool. So it looks like, what do we have to do? We have to do K1 by K0. Looks to me like K1 by K0 is basically 1 by 2. Right? Right. And sure, K1 की units हैं, K0 इसकी unit, K1 की unit is just minute inverse or second, okay, second inverse. इसकी होगी, what is the unit of this? This is mole per liter and also second right here. So technically, this is going to be liter per mole. Option A. What do you think? दोस्त लोग क्या हुआ? सवाल ज्यादा भारी हो गया क्या? Lakshya, when will you have 11th live classes? Lakshya, you can check my sessions out on the JEE channel. The content is exactly the same for the NEET and JEE students because आपका syllabus same है. Practice sessions अलग है. Yeah, my friend's going to cry. No, it's okay. He's really good at his job. He's a one-man army. He's amazing. Can you explain the fourth option? Smasher, which one are you talking about? पिछला वाला क्या? I'll explain the fourth option. I missed that. Specific, catalyst specific, I missed that. Lakshya, I've explained to you. Go to the bento link and you can go check out my sessions on the JEE channel. I do them there. I do the live sessions 11th K there. I'm doing the practice, NEET ki practice on the NEET channel, JEE ki practice on the JEE channel. Theory sessions are the same. Okay? 12th I'm doing, 11th I'm doing that. But awesome. Thank you for asking, Lakshya. All right. This is answer iska half hoga, right? Smasher, anybody else who's still here surviving? These are difficult questions. I'd understand if you want to skip them. But let's say that this is for people who want to score like 650 plus, right? Because they will choose the last, they go 1 to 35 questions are chill, right? Very doable. If you cover syllabus, they're chill. 36 to 50, those questions usually will have things like this. जिसमें आपको बैठ के या तो फिजिकल वाले क्वेश्चंस फॉर श्योर वाले मार्क करो या ऑर्गेनिक यू नो प्रॉपर्ली और इनऑर्गेनिक यू नो प्रॉपर्ली. 36 to 50 आर प्रॉपर्ली वाले क्वेश्चन, इसलिए यू हैव लाइक 10 out of 15 वाला चॉइस. So it depends. Like if you are confident about this sort of stuff, you will definitely mark it. This is it. Yeah, 0.5 मुझे answer आया इसका. Okay, before I go to the next question, here's the next question. Smasher asked about catalyst sometime very specific in reaction. Smasher, do you remember if I use अच्छा आपको ऐप दिख रहा है ना, रुको इसको हटा देना है, ये दिख रहा है. If I use different things, yeah, specificity of catalyst NCERT में है. Let me just show you so that it is easier and you don't forget it. Edge खोल के NCERT specificity of catalyst for hydrogenation. Hydrogenation वाला example था ना. If you use, Edge is so pointless. Oh God, bro. Like Edge is okay, but the Bing is like pointless. Specificity. Okay, एक second. There was these specific things, right? Hydrogenation के लिए, if you use nickel, you get some product, you get this, you get that product. Basically, depending on what catalyst you use, you will get different products, right? Organic ka tha, I'm just trying to find out where it was. I'm not sure if it is in kinetics or is it in surface chemistry. So that's what I'm looking up right now. You can also check this out, okay? It is definitely in NCERT. I'm just trying to see kahan pe hai. And I'm still using Bing, hoping that they'll figure it out. But Bing is bad, bro. Like it is pathetically bad. But ठीक है, we'll give it one more chance. Specificity, no. Catalyst. So you can see what I'm doing. रुको. I'll share my screen with you as well. It's not something हम लोग secret कर रहे हैं. Yeah, catalyst. अरे भाई ढूंढ ले catalyst. Oh, there you go. I think you found it. Did you find it? No. Let's go backwards. Catalyst. I have a feeling यहीं पे है कहीं पे. No. No, it's not here. I've done it in my sessions, man. Anyway, so depending on what catalyst you use, you'll get different products, okay? The same reaction, exactly same reaction. That's what I mean by specificity. And when you do organic, you can figure it out, okay? Oh, you're not able to see my screen? That's brilliant. मैं अभी तक ये सब कर रहा था, आपको स्क्रीन मेरी दिख नहीं थी. I'm on NCRT. All right, let's get back to this. If you still have a doubt on this, come to you know where to find me. Yeah, I am on Telegram, Discord. I teach Chem. Ping me there. I'll give you resources to read. I'm not able to find it on NCRT right now, but yeah, they are definitely specific. उसमें कोई doubt नहीं. All right, this is the next question. Match the following. You got some activated complex, all of that. Activation energy of forward reaction, change in enthalpy. This is a little nutty because what? Oh, A, B, C, D, E. Okay. Oh, I see what's happening. I see. We'll do one or two more. Let's just finish this up. दो सवाल हैं इसको कर लेते हैं. I know थोड़ा लंबा सेशन हो गया. Just दो ही सवाल इसको हैं. This one and the next one. Then I'll let you go. I know you guys have another class with Ankita ji later on, right? At 7. Let's do this and the last question and we'll wrap it up. Okay. So out of these reactions, out of this, let me remove these and let's do it backwards. हम लोग उसको सब mark कर लेते हैं क्या क्या बना है इस ग्राफ में. This A, I don't know what that is. This C, I don't know what that is. B, I know is activation energy of the forward reaction. This is B for sure. Okay. B plus E is basically the activation energy of the backward reaction. This is what I see. आपको दिख रहा है ये? Are you able to also see this? Okay, great. E is delta H. Do you see that? मुझे जो दिख रहा है मैं मार्क कर रहा हूँ. I'll do match the following बाद में कर लेंगे. ठीक है? Let me just write down what I see. So E is definitely delta H and delta H happens to be negative in this case. Okay, ठीक है, देखते हैं. और क्या क्या ऑप्शन है? Potential energy of reactant, potential energy of product. Oh, interesting. अच्छा. So A is reactant obviously and C is product, potential energy. ठीक है. Did we miss anything out? No, I think we have got everything down to the letter T. A is activation energy of forward reaction. No, it is B. So I feel it should be B matching with 1. B matching with 1. B matching with 1 is either at C or D. इन दोनों में B matching with 1 है. So we have eliminated options A and B. Okay, let me show you. A and B gone. आपको मेरी स्क्रीन अभी नहीं दिख रही है तो let me go back and show you the screen. So from this, I've got activation energy to be the first one. ठीक है, activation energy of forward reaction. मेरे हिसाब से that is going to be B. So B must go with 1. So we have got done with A and B. Okay, let's look at next one. Change in enthalpy. That I'm sure of is E. I've already written that over here. Yeah, मैंने यहाँ पे mark करके लिखा है. It is going to be change of enthalpy is going to be E. So change enthalpy मतलब E must go with 2. E with 2. Okay. So I feel C is the answer. What do you think? C is good? Yeah. Raju Smasher भाई साहब. Kanaya, आप हैं यहाँ पे? I think it should be C. Let's mark C. Yeah. Awesome. Theoretical question, but I like this question. It tests stuff so much in detail. Like it goes completely into, yeah. I like it. I like this. Technically, ये potential energy of products and reactants, now you can't really tell. There's no way for you to know H. You can only do delta H, right? That was the idea of thermodynamics that was important. Okay. Let's say last question. AIPMT 2003 का सवाल. We are in the right cohort. Definitely. हम लोग कर रहे हैं मेडिसिन के भारी सवाल. AIPMT 2003 का सवाल. The activation energy for a simple chemical reaction is EA in the forward direction. The activation for reverse reaction क्या होगा? I like this question. So what this is saying is कि activation energy, देखो मैं दो diagram बना रहा हूँ. I'll tell you why I'm drawing two diagrams. Right, in this case, delta H is positive. In this case, delta H is negative. You'll see why I've drawn two of them. Now in this case, this is EA forward. In this case, this is EA forward. Okay, now that I've drawn all of it, activation is simple chemical reaction, needing forward reaction. The activation is reverse reaction, कोई भी हो सकता है, right? Now if I do this, see in this case, EA backward कम हो गया. In this case, EA backward ज़्यादा हो गया. So it depends on whether the reaction is endothermic or exothermic. अगर endo है, then EAF is greater than EAB. If it is exo, then EAB is greater than EAF. ठीक है? And these are all positive values. ठीक है? So there's no concept of putting a negative sign or anything of that sort. Not for EA anyway. ठीक है? Nice question. CBSE, AIPMT, those are things. Oh, पहले CBSE करता था conductor. That's interesting. खैर, nothing to mug. Beautiful question. All you've got to do is first principle से चीजें करनी है. ठीक है? Awesome, right? Really nice way to close this session out. Is this okay? My friend's going to cry. No, he's not going to cry. Are you guys here? भारी भारी सवाल हो गए. I understand you're all NEET aspirants, and it's very unlikely that you're going to get a question like this in the actual NEET exam. I understand that. Because आजकल NEET exam is very high scoring and not as complicated as what it used to be. Right? AIPMT, as you can see, काफी ढंग के सवाल थे. Right? These are difficult questions. Not everybody's going to get this right. You're going to have to draw things and do it properly. Anyway, I feel this is correct. I'm going to mark this. And there you go. We cracked activation energy. That's great. Energy activation reverse reaction less than that. Yeah, cool. ये तो हमने डायग्राम से दिखा दिया है. यही चीज थी. बाकी इससे जरूरत नहीं है. By the way, you can also just go and check your performance. It seems like we are doing well in everything other than memory. Focused. Look at that. I've got a 0 bar on memory. Oh, that's awesome. Anyway, we're doing pretty well on most places. Brain power, I think, needs to reach a certain thing. We're doing pretty well, huh? This thing. 90%. 20 में से 18 सवाल सही. 20 के साथ हमने और 4-5 सवाल यहाँ के. So we did around 25 questions. I guess 20 मतलब, yeah, 5 4s are 20. 24, 25 questions we did. Around 1.5 घंटे में 25 सवाल किए, which is quite a lot, bro. Quite a lot. But I had fun doing this. If you like these kind of sessions, want me to do more of them, comments में डालो. ठीक है? I'm going to come to you with haloalkanes tomorrow. Let's get back to organic. हम लोग physical तो खत्म कर दिया है 12th grade का organic. Let us start. If you want, I think if you need to, please revise stuff before it. But don't worry, we'll do SN1, SN2 reaction फिर से यहाँ पे. Although in your syllabus right now it is supposed to be in the 11th grade. But जब आप 11th में थे तब तो 12th में तो 12th में बोला था पढ़ाएंगे. अभी आप 12th में अगर बोलो 11th में, so for you guys I'll teach it right now here. For the 11th students as well, I'll teach them SN1, SN2 as well. ठीक है? Anyway, चलो, thank you everybody for your time. That was it from me for now. If you haven't checked the app out, go and download it. It has some very, very cool practice questions and videos and everything else. Yes, Raju साहब, 1.5 घंटा हो गया है और कितना समय बैठेंगे हम हमारे साथ. Thank you for sticking around for so long. Next class is Ankita ji's at 7 o'clock. That's bio, right? So see you around. Bye. If you want more practice, go to the app. वही है यहाँ पे screenshot पे. Description में link है. If you want to check out my other sessions, description में bento link है. Also, there's a pinned comment right here. Okay, see you. Bye. कल मिलेंगे with Hello Alkanes. Tata. See you.